Hi, all. In this video we will just take you through a little bit of data cleaning, the concepts called data cleaning. So that is what we are going to see here. So I won't be taking much of the time through the slides, but rather than that I would take you to the lab. So all these contents are actually of Bahrain Polytechnic and is prepared by Dr. Mahmood. And yeah, I'm just taking you through these concepts, that's all. So sharing this is not allowed. Okay. And yeah, so cleaning data sets for modeling AI. So as I have already mentioned in the class that whenever we have a machine learning process, the majority of the time is actually spent on the data cleaning. So why? Because only if we have a proper cleaned and prepared data, we will be able to get good results or good insights or inferences, as I used to say in the class, right? So what do we do in this cleaning? So in this cleaning we need to remove the duplicates, we need to handle the missing data, we have to fix the human errors or the other errors which is actually given by the sensor data or whatever it is. All those errors could be avoided. Why? Because we don't want any biased results, right? Our aim is to remove all the biased results, and we want to get a better accuracy, and say the model that we are actually building should have good reliability, right? We should be able to rely upon the model that we build, right? And we should be able to trust the predictions that is actually given by the ML models that we create. So in order to reduce all this noise and to speed up the training and to enhance the adaptive learning, that is the major capability of the ML model, right? We need all this data cleaning, and data cleaning basically takes almost around 80% of your time, so that you are going to build a model which can be fed with the most appropriate data, which can provide you the best results, right? So that is what the crux about this data cleaning. So when you look at the data cleaning, there are various ways of doing it. I mean, like, we can remove the missing values, right? So that is one thing. And if you look at it, we have various functions available in the package pandas. So in the pandas we have so many functions available, so I will just quickly go through it and then I will take you through the lab itself. So there is null, okay, and there is something called drop na, okay. So these are all certain functions which you will be actually seeing in the lab as well. So this is exactly what we are going to see in our class. Now going back to the over to the lab, okay, I wanted to quickly tell you that we are going to see certain exercises where how each and everything works, right? So the first one is nothing but, if we have a data, then we need to remove, or we need to identify the missing values itself, right? So for that we have got this is null. So I am also using the Google Colab, the drive itself I am using, and in the drive, basically, I have actually categorized it as week 4, etc. And data set.csv is the file that we are going to use. So if you could see that, there is a category, price, rating, stock, and discount. And if you could see price and rating and the discount, three of these actually attributes are actually numerical attributes, and if you see category and the stock, they are categorical attributes, right? So this is the first understanding that you should have, and there are a lot of missing values in that. Now when you look at it, when I'm actually, here what am I doing is I'm just reading the data, right? I'm just reading the data, pandas as pd, which is I'm renaming the pandas as pd, and pd.read_csv, because that's a csv file, and I'm trying to perform some operations upon it, but it is actually showing me some error. What is error? That is the file not found. The file not found error is there. So what I need to do is that I need to import because I have not imported, this is a session, right? In this session I have not imported the Google Drive, right? So the first thing which you have to do is that please import. This is the standard lines that you can use for importing the drive. So please import the drive. So once you have done this successfully, it will show you like the mounted at the content drive. So content drive is nothing but the root of your root of the Google Drive. Okay, so now once you get that, once you have actually the drive is mounted, you could see the drive, and you can just traverse through that and take the path. Okay, this is the copy path, and I'm just giving that path here. That's all I have done. right? So I have actually, instead of directly using dataset.csv, I have my dataset here, and that path is actually taken and given it here. So it is on the content drive is the root of my drive, and in that I have a my drive, and then in that inside Colab notebooks IT7001, this is the path for this particular one. Now what am I doing here? Here it is nothing but df.isNull.sum. So what am I doing? Whatever is there, whatever all the missing values, I will go and check for each and every missing value in each and every column, and I will take the sum of all those things, and I'm printing it as an info. So when you look at here, okay, so each column I have taken, and I have actually did the summation of the missing values. So in each column, in category column, I have almost like 2748 missing values. In the price column, I have 174 missing values. That is the meaning of this. Okay, now what I have done is that I have simply printed the information about it that you already have seen in the last class. Now the next one is, okay ma'am, we understood that we have missing values. Now how can we remove it, right? So for that also we have function. We don't have to write anything from the scratch. Okay, so there is a beautiful function called drop NA. What is the meaning of drop NA? Drop NA is nothing but whatever is all are the null values, you drop them. So how would you know that whether it has to be dropped? In place equal to true. That means that whenever I have a missing value, so whenever I have a missing value, that missing value considered as a true value, and if I have something true, then you would simply drop it. So we will remove from the data frame if the df contains a missing value, and these changes will be directly applied to the data frame. That is very, very important, that you will understand in course of time when you are really looking forward for the computational challenges and the computational resources that is utilized by the data frame later in any of your applications. You will understand this point very clearly. Okay, so now when you look at this, you are actually taking the data, right? You are reading the data, and you are actually dropping whichever is there as true. You are just dropping it, right? And when you look at it, you can understand that you are actually writing it as a cleaned data set. So when you're looking it as a clean data set, you are getting that as a cleaned data set, right? So you have dropped all the missing values. Now you are again printing whatever it is false. That means that the non-missing values, if you want to print, you are actually printing it. So this is nothing but your non-missing values actually we are printing, and we are actually putting it over to the clean data set. So what happens is that in your drive, now what will be created? A new CSV file, cleaned data set will be created. So if you look at it, you will have a data set with no missing values, with only non-missing values, which is false, will be written over here, right? So that is nothing but which actually happens over here in this. So now the next one is basically called as a operation called as a imputation. So imputation is the word meaning itself is some changes that is actually done, and how are you doing the changes? You are actually doing some imputation based on the mean or the median or mode. So these are the three different things. So what are we basically doing is nothing but we are replacing all those missing values. Okay, and the missing values are sometimes represented as n, none, or 0, or all those are a constant, right? So sorry for that. So those missing values are actually replaced by the mean, right? So that is nothing but we are doing. So again, if you look at it here, we are actually reading the data set, and we are just printing all the values before the imputation. So before the imputation, these are all the missing values that we have, right? Now what are we doing in the imputation? Okay, so we are selecting all those data types. We are selecting df.select data type, and what kind of data type are we selecting? We are selecting all those number data types. So in the columns, if you have data type which is actually number, then you are actually putting it into numeric columns, and in that what are you doing? You are actually filling everything with the mean. Alright, so that is exactly what we are doing. Your fill NA will simply fill, but what you have to fill? You have to fill them with the mean value. So you will take the numerical column, and you will take the mean of it, and you will update all those missing values with this mean values. That is what exactly what you are doing. So after imputation, what are you doing? You are actually taking the sum, and you are actually printing. So when you look at it after imputation, if you could see all the numerical say if you could see here, why ma'am category has 2748 and still stock has 1342? Yes, because your data set, if you could see, this category and the stock is actually non-numerical values. Okay, so non-numerical values doesn't have any changes. We have taken only what type, what data type, we have taken only the number data type. So what all are the number data type? We have these three data types, which is price, which is rating, and the discount. Okay, so when you look at it, price and the here the price and the rating and the discount, if you could see, all of them are actually zeros, and there is no changes which are actually happened to this categorical data sets, right? So this is exactly what you could see. So here still in the category and the stock, if you could see, you can still see NAN here and there. Because why? Because we have not done anything upon the category and the stock. But when you look at the price, rating, and the discount, you could see that all the values, missing values, has been replaced with the mean value. Right? So the explanation are here, and if you want, you can actually go through it. Now the imputation by median. So what can we do when we are actually doing it upon the median? So right, this is exactly the same thing, only there is no major difference. So till here it's all the same, and you are actually here including the number alone, but only difference is that dot mean, instead of dot mean in the previous function, here it was actually dot mean. Instead of that, we are actually calling dot median. So what happens again here is that we get the values, but these values will be replaced with the median. Now the next one is actually by mode. Okay, so when you look at it, the mode actually works for both the numerical and the categorical values. That is something which you have to keep in mind, and which you have to keep in mind maybe for your quiz as well. So here when you look at it, you are actually taking all the values, and here everything is all the same, but the way that we actually, so for each column in the DF columns, what are we doing? We are filling. What are we filling? We are filling with the column dot mode. We are actually filling it with mode, and for only those values which are missing values, right? This is what exactly what we are doing. So when you look at it, you get all those imputation. After the imputation by using mode, all the categorical and the numerical values has been replaced with the mode value. So this is something which you have to keep in mind. So the mode actually works for both the numerical and the categorical value. So this particular point is actually very, very important, even important for your quiz. Now the next one which I wanted to show you is about removing the duplicate data. So how can you actually remove the duplicate data? So say just imagine that you are actually given with the data, right? Ali, age. So this is kind of a key value pair. So you have been given with a dictionary, and from this dictionary you are actually creating a data frame which is actually called as DF. So when you look at the DF will look like this. So it will have all the values, and created in the name, age, and department. It will also have a index associated with it, right? Now you are checking all the duplicate rows. When you check the duplicate rows, so DF dot duplicated. Okay, so what you have done is that you are actually calling the duplicated function, and you are applying it upon the DF. So when you look at it, you could see that there are certain values which are actually duplicated. So when you look at it, Ali is actually Ali, this one, right? So this is actually repeated twice, right? So you can actually identify that whether certain values has been duplicated or not. Okay, this is exactly what you are actually doing. Now what you could do is that you are actually going to clean them. How are you cleaning them? So you are actually calling the drop underscore duplicate function. So when you look at the drop underscore duplicate function, so this one, drop underscore duplicate function, it is applied upon the DF, and you get your results in the DF cleaned, and you are printing it. So when you're printing it, you could understand that it has been removed. Okay, so the main thing which you have to keep in mind here is that the duplicated basically returns a true or false series. True means the row is the duplicate of the previous one. False means it is the it's the appearance, it's the first appearance. So that's a main thing which you have to keep in mind. So true and the false. Okay, so I just wanted to take this out, because for the duplicated alone I want you to take this and copy this. I'm just copying this so that it is easier for you to understand here. So the duplicated, in the duplicated, how it works is that, and I'm just taking it as like this. I'm just copying it here. See, this is the understanding which I want you to have. So true means it is a row is duplicated 1. So when you look at it here, true means it is duplicated 1, and false means it is the first time experience, it is actually shown first time, right? Now the next one which you could see is that the fixing the inconsistent labels. Okay, so for the inconsistent label example also, say what do you mean by inconsistent label? That's the first understanding that you should have. So when you look at the inconsistent label, say here we have a dictionary where employee is given with the names and the department is given with the departments, but when you look at the department, sometimes I have written it as ICT, then small ICT, capital I and small CT, all those informations are there. So but as a human being, I understand that ICT, all these three things are actually the same, but as a system it will take as all these four actually. So all those things are actually in a different one. So how will the system understand, and how can we make the system understand this inconsistent labels? So this is the data, and we are actually creating a PD. We are creating a data frame using the pandas PD, and we are printing the DFs. So when you look at it, this is our original data set, right? There is no difference. This is our original data set. Now what are we doing? We are converting everything into lower, and we are stripping all the spaces, right? You have already learned the strip function. So now what are you doing? You are replacing all the variations. So how are you replacing the variations? Replace HR with HR. So you are just making it all into a simple one, into a common one, and you are actually putting it into the cleaned one, right? When you print the cleaned one, you could see that these are the cleaned ones. We have made everything into a common one, and then finally you are actually printing only the unique ones to see which are all the unique departments which we have ICT and HR right? So this is nothing but you are removing all the inconsistent ones. And then comes the incorrect data types example. So in the incorrect data types examples, what we are doing is that, say we have data types of in multiple ways and multiple types, but we want to make it into a common one. So what can we do, right? So you have employee, you have age, you have salary. So when you see the salary here, you have this is the salary, and you have joining date, right? So initially you are actually making it into a data type. So when you look at it, this is your original data type. Okay, this is the original data type. So it's all showing like salary and everything. It is just shown as an object. Okay, and now what are we doing? We are actually converting the age into age has to be an integer. So I want everything. I don't want age to be a text. I want age to be an integer, and I want my salary to be a float, and I want the joining date to be a date, right? So this is exactly what we are actually converting. We are converting the data type into its own data types. Now we are again printing, and we are trying to make it print. So when you print it, you could see that it is integer, it is float, and it is date time, etc. And when you now use it, it will be it will be considered as a number, as an integer, right? So this is one thing which you have to do with the work on with the data types itself. Then comes, as I have told you every time in the class, that everything and anything in machine learning, your system will be able to understand only when it is converted into some number. So we need to perform certain encoding to make our system understand. So we have already seen this label encoder in the last class. So label encoder, as I told you, like it is in the SK package. In the SK package, it is in the pre-processing module. We are importing from there, right? And consider this as your data. It's a dictionary with employee and its values, and gender its values, and department its values. We are initially making it as a data frame. So when you look at it, this is your original data frame. Okay. Now what are we doing? We are actually applying the label encoder. So the label encoder, we are giving the name LE. Okay, now LE, and this fit transform is the function which will actually help you to apply which function? This function, LE function, upon what? Upon the gender. Okay, so we are applying the LE, that is label encoder, which is actually by using the fit transform function onto the column gender. So when you look at the gender, this one we are trying to apply, right? So what are we expecting? We are expecting some zeros and ones, right? So that is what is happening here also. So in the gender, if you could see that either it is true or false, basically you will get it as 1 or 0. Now the next one is basically pd dot get dummies. Okay, and the df, you are passing the df and the column department. So normally when you see this particular line, this is basically will act as a one hot encoding. So what do you meant by one hot encoding? You have already seen it in the last class. Say if you have HR and you have IT, it will actually expand, right? So instead of one department, you will have two department columns which tells department HR, department IT, so that the values are very clear. Okay, we don't have to give any more values over to it. Say if you have the first one is actually HR, so HR is actually true here and false. So you have two different columns. It is actually split into two different columns, department HR, department IT. So now it is very clear for you. Okay, this is definitely from this Ali is definitely from HR department, Fatima is definitely from IT department. So it is very clear for you when you are actually giving the values like this. This is nothing but one hot encoding. So encoding basically helps you to, it's a representation and it will help you to identify your data in the most appropriate way as possible, so that it can contribute to the analysis of your ML model, right? Now comes the outlier detection. So outlier detection is very important. So whenever you have data, and say just imagine that you are doing a bank transaction every day only up to 200 BD. Okay, suddenly your account has got a transaction which gone up to 1 million BD. So what is that? That 1 million BD transaction which has happened in your account is actually called as an outlier. So maybe it is a fraud detection. So you can actually use this outlier detection for maybe fraud detection, because maybe your card is actually taken by somebody else and they got it and they were trying to pull out the money in such a big amount, right? So it could be an outlier detection. So this kind of outlier detection is very important when it comes to ML models, right? So for that, if you want to say, if you're working with the PD, then this is your pandas, and this matplotlib.pyplot as PLT is nothing but your for all the visualization purposes, and this is your data. So when you look at it, you have data, you have employee, and followed by all the names, and salary followed by all the salary details. The first thing which you are doing is making it as a data frame. So when you look at it, you have your data frame, that is employee, salary, and all your data is actually properly and beautifully indexed with the help of an index as well. So that is the beauty of it, is making the data more structured, right? And you are printing it here, yes, that you have seen. Now the next one is basically called as a IQR method. So what is this IQR method? IQR method is nothing but, say your whole set of data is taken, and you will take the 25 percentile of the data and 75 percentage of the data, and you will do a subtraction on that. So that is exactly what you're doing here. So they are called as a quantile. So whenever you have 100 data, you can actually divide that 100 data into 4 different parts. The first 25 will be called as the first quantile and the quartile or quantile, and the second one will be called as the second quartile, and the third quartile, and the fourth quartile. This is how your data will be split. That is as if you have an year, you are splitting your whole year into 4 different parts. It's the same way that you are actually, you have to map and think it here. So the first quantile data is basically, how are you doing it? You are actually taking the whole of your data, you are multiplying by 0.25. That means that 25 percentile of your data is basically considered as the Q1. And then the last part is actually the 75 percentile will be considered as a Q3. And what is the formula for outlier detection? Outlier detection formula is IQR. IQR is interquartile range. So interquartile range is nothing but Q3 minus Q1. So how will you find out the outlier? The outlier detection can be done by using this particular formula, by using IQR. So your Q1 is nothing but your first quartile minus 1.5 into IQR. Okay, if you have a value which is lesser than this, you will call them as outlier, and if you have a value which is greater than this, you will call them as outlier. So this is the idea which you have to keep in mind. Now when you look at it, so this is exactly what we, so if your salary values is actually less than the lower bound, then we will call those kind of values as outlier values, and if you have your salary value which is greater than the upper bound, that also we will call it as outliers. So this is how you will actually detect the outliers. So when you detect the outliers, you have two different outliers, Hussain and Aisha, who is having 60,000 and 90,000 salary. Now how can you do it? Can we visualize that with the box plot? So you are actually using the box plot, plt.boxplot, and what are you actually depicting? You are depicting your salary, okay, and you want it to be in the vertical, so that's why you actually give it like what you want the salary to be, and all those things has been actually given. And then the salary distribution with outliers, that is my title, and the X label is nothing but salary, and I'm just showing the data. So when you look at it, all my data is here, but there are two different values which are actually not coming as part of the original data itself. So these data will be considered as the outliers in this case. So you can actually identify the interquartile range, and you can apply the formula for the lower bound and the upper bound using the IQR. Okay, and if the lower bound is less than Q1 minus 1.5 into IQR, then you will say that those values are outlier values, and you can have higher outlier values also. So in this particular case, we have only higher outlier values, we don't have any lower outlier values, right? So this is exactly what you have to identify and understand. So in this one, we have actually seen a little bit about the data cleaning itself. So in the data cleaning, what can we do? In the data cleaning, how can we actually clean the values in different ways so that we get the right data, right prepared data, which could be fed into the ML model to get the right insights or the inferences, right? So this is exactly what we have seen in this class. So please go through it and make your hands dirty. Once you are ready with it, go and explore a little bit more onto it. There are a lot of resources which are already available, which will help you to identify and understand data cleaning in a much more better way. Thank you so much. All the best.